Okay, welcome back. So I'm going to start my third video, starting with number 10 on the CUA review. So it says complete the table given the rule or complete the rule given the table. Okay, so it's giving us in number 10A, it's giving us a bunch of x values or inputs, and we need to find out what are the y values. So what we're going to do is we are going to substitute these x values right here in for x into our function. Okay, so what we're going to do is we're going to substitute -1 in for x. When we do that, we have -3 times -1 plus 4, and we get 7. When we substitute 0 in for x, we get 4. When we substitute 1 in for x into this function right here, we get +1. And then when we substitute 2 in for x, we get -2. So notice this makes sense right here, because if you think about writing the function rule, these are all going down 3, and our y-intercept when x is 0, y equals 4. So this makes sense. Okay, so let's look at 10b. 10b, we need to write the function rule, and it gives us a completed table. So let's find the pattern for the change in y. The y's are changing by 3 each time, +3. Your x's are changing by +1. So my change in y divided by my change in x would be 3, therefore my slope is 3. Okay, now I need to figure out what is my y-intercept. So I see when x is 0, y equals 5, therefore my y-intercept is 5. So if I write my function, I have f of x equals 3x plus 5. If I want to make sure this is the correct rule, all I have to do is check these points right here and see, when I substitute 1 in, do I get 8? Well, yeah, because 3 times 1 plus 5 is 8. And that's a quick way to check. Okay, so let's look at C. C is 3x squared, so it just gives us a bunch of x values that we need to substitute into the function. So if we substitute these in, so first if I substitute -1 in, I have 3 times parentheses -1 squared, which would be +3. 3 times 0 squared would be 0. 3 times 1 squared would be 3. And 3 times 2 squared is 4. 4 times 3 is 12. So that would be our completed table. And our last table, or actually second to last, sorry. Our second to last table, we are giving f of x equals 2 to the x power. So we're going to substitute -1 in for x. So 2 to the negative first power is 1/2. When we plug in 0 here for x, anything to the 0 power is 1. When I substitute 1 in, 2 to the first power is 2. And last, 2 squared is 4. Okay, and then let's look at E. E wants us to write the function rule, so let's figure out the pattern of the change in y. These are all changing by adding 25, and these are all changing by adding 1. So my change in y divided by my change in x would be my slope, so my slope here is 25. When x equals 0, there's my y-intercept. My y-intercept is 0, so b equals 0. So my function would be f of x equals 25x plus 0, or just f of x equals 25x. Okay? And number 11 says, which of the functions in number 10 are linear? Explain how you know. Okay, so just looking at these, to tell if something is linear, it has to have a constant rate of change, meaning it changes by the same number each time. So if I look at A, my y values are changing by the exact same value every time, and so are my x's. So my y values are changing by -3, but they're all changing by subtracting 3 each time. So therefore I know that A is linear. I also know b is linear because all of my y's are changing by positive 3. Okay, so b is also linear. C is not linear. There are two ways to know. First of all, you see that it is x to the second power, so you know it is a quadratic function. Or you just look at the y values right here and notice that the first pattern is to subtract 3, the next pattern is to add 3, and the next pattern is to add 9. It is not changing at a constant rate, therefore it is not linear. D is also not linear, it's actually exponential. You can tell by having the exponent be a variable, or you can look at the y values. Notice that these are not changing by the same amount. Here I'm adding 0.5, here I'm adding 1, and here I'm adding 2. I'm not adding the same amount or changing at a constant rate. So therefore D is not linear. E is linear because I'm changing by positive 25 every time. So E is linear. So my functions that are linear are A, B, and E, and explain how I know. I know because those are the only ones that are changing at a constant rate. Okay, so let's look at number 12. So number 12 says, for each pattern, write a rule and then answer the question. Okay, so in order to make this easier to see the rule, I'm going to draw a table. Okay, so I'm going to call my x values tiles. So these are my x values. I'm going to call my y values perimeter. So zoom in. Okay, so when there is one tile, the perimeter is 3 inches. So with one tile, the perimeter is 3 inches. When there are 2 tiles, the perimeter is 4 inches. When there are 3 tiles, the perimeter is 5 inches. And when there are 4 tiles, the perimeter is 6 inches. Okay, so it now wants me to write a rule that relates the number of tiles, T, to the perimeter, P. Notice that I used X and Y. So X is my tile, so I'm going to call my tiles are X. You could use T and P if you want, but we typically just use X and Y, so I'm just going to stay kind of similar to what we've already been doing. So the perimeter is P, I'm going to call it Y. Okay, so my tiles are X, and my perimeter is Y. Okay, so write the rule. Well, I have to figure out what's the change in X divided by the change in Y. My Y's are changing by positive 1 each time. My X's are changing by positive 1 each time. So therefore, my slope, my change in Y divided by my change in X, is 1 divided by 1, which is 1. Notice that this one's a little bit trickier because I don't see as 0 for an X value, so it's not as easy to identify my Y-intercept. So what I'm going to do is I'm actually going to go backwards 1. So I want to figure out when X is 0, what does Y equal? So I know when X is 1, Y equals 3. Well, what about when X is 0? If I'm adding 1 to get this direction in the pattern, I would actually have to subtract 1 to go backwards. So therefore, when X equals 0, my Y would be 2. So when X is 0, my Y value is 2, therefore my Y-intercept is 2. So now, writing the correct rule, I would have Y equals 1x plus 2. And this should have been B. Remember, my Y-intercept is represented by B, the variable. Okay, so my function rule there is Y equals 1x plus 2. Okay, so find the perimeter for 14 tiles, show your work. Okay, so my tiles I labeled as X. Okay, so therefore it needs, in order to solve this problem, I have to substitute 14 in for X, my number of tiles. So I'm going to substitute 14 into X into this equation right here. So I have Y equals 1 times 14 plus 2. 1 times 14 plus 2 is equal to 16. Therefore, the perimeter is 16 inches when I have 14 tiles. Okay, and then the last one, how many tiles are needed if the perimeter is 52? Notice I labeled my perimeter as y. So I'm actually going to substitute 52 into y. Okay, so I have 52 equals 1x plus 2. And now we have to go back to Unit 1. How do I solve a one-step equation? I have to isolate x. I do that by subtracting 2 to both sides. Oops. When I do that, these cancel, and I'm left with x equals 52 minus 2, which is 50. So therefore, how many tiles are needed if the perimeter is 52? You need 50 tiles. Okay, and then last problem on this page of the review. I'm given another pattern in different pictures, so I'm going to set up another table. Again, I'm going to stick with x and y, so my picture number is going to be x, and my number of squares are going to be y. If you wanted to use n and s, it would be the same thing, and that is perfectly fine. Okay, so my x is my picture number. Sorry, it's hard to write on this. So my picture number, pick number. Okay, and then my number of squares is y, so y is number of squares. Okay, so I look at the pattern in picture 1, how many squares are there? So in picture 1, to me, there are 5 squares, so there are 5 squares. And number 2, I'm going to count them up, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 squares in picture 2. Oops, picture 2. 9 squares. Okay, in picture 3, I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 squares. And you may already start seeing the pattern. And in picture 4, I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 17 squares. So now I have to figure out how much are these y's changing by. They are changing by positive 4 each time. And my picture number is changing by 1 each time. So my change in y divided by my change in x. So my slope is 4 divided by 1. So my sorry, I thought the video just stopped there for a second. Okay, so 4 divided by 1 is my slope. So I have m equals 4. And now, again, I don't see my x equals 0 in the table, so I have to figure out, well, what's my y-intercept? So if I go backwards 1 here, when x is 0, instead of adding 4, I have to go backwards, so I would subtract 4. So 5 minus 4 would be 1. So when x equals 0, y equals 1, therefore my y-intercept, or my b, is 1. So I have to write my function rule. My function rule here is y equals 4x plus 1. Okay, and again, I could check to see if this is right by just plugging in one of the x values. So 4 times 2 is 8. 8 plus 1 is 9. I can see that it works. Okay, now I need to answer these last 2 questions. Find the number of squares needed for picture 15. Okay, so picture number is x in my case, so I'm going to substitute 15 in for x into my rule. Okay, so I have 4 times y equals 4 times 15 plus 1. So 4 times 15 is 60. 60 plus 1 is 61. So therefore, I have 61 squares needed.